Okay, so should I share my screen now?
I'll do a quick intro, Audrey, and then I'll hand over. Give me 5-10 minutes or so just to go through a few housekeeping slides and things like that, and then we shall make a start. So, okie doke. So yes, welcome everybody to the July Welsh Azure User Group Meetup. Thanks for tuning in, coming along, saying hello, and all of that good stuff. Just a quick slide to show who is the organising team behind the scenes. As always, this is a community user group, so we're always open to suggestions, any particular talk topics that you'd like to see on the user group, feed them through to any of us there. We got a feedback form as well. I'll put the link to that up at the end of the session. Yeah, but feel free to reach out if you want to speak, if you've got an idea, anything like that. We're all open. We're all ears, as they say. So yeah, or just add us on LinkedIn and Twitter. Feel free to reach out and say hello if there's anything else you'd like to talk to us about, of course. So tonight we have got two fantastic speakers who are on the screen with us now. We've got Audrey that will be joining us in about 5 or 10 minutes or so now to talk about GitHub Actions versus Azure DevOps. Or DevOps Pipelines. I know it's one of those questions that's been flying around the community for a good couple of years now. So yeah, that's going to be an absolutely fantastic talk. Looking forward to seeing that one, Audrey. And then we've got our very own Mr. Fortunka is going to come on and talk to us all about Azure Container Apps. So again, two really interesting talks as far as I'm concerned. So hopefully everybody on the call gets some stuff out of that as well. As per usual, I mean, for timings, usual format this month again. Like I say, Audrey will be kicking off in about 5. We'll probably be a little bit earlier than 1:45, so we'll kick off with Audrey, and then Matt will follow closely behind Audrey. Then we've got the quiz as well. Our quiz master, Mr. Fortunka, is here already and set up. Well, we've got a couple of Amazon gift vouchers up for grabs, so we'll stick to the whole first and second place prize winners again, because we love to give away a good Amazon voucher. Who doesn't like an Amazon voucher, eh? It's like Christmas all at once, isn't it? So yeah, there's our timings for this month. Few housekeeping rules. Obviously, please, everybody be courteous to each other. There are no silly questions. You know, we're all here to learn. We're all here to learn from each other and the speakers. So all we would ask is that you stay on mute unless you're invited to speak and come off mute by one of the speakers. Feel free to use the chat facility to ask any questions or join in, you know, have a little bit of fun. It usually goes a little bit like that. So just use the chat facilities. And if the speakers haven't seen any of those questions, we'll try and chime in at an appropriate point and ask the speaker the question. Yeah, if you can leave us some feedback, like I said, I'll put the link up at the end of the event just to give us a little bit of feedback on this month's event, and like I say, any future bits and pieces you'd like to see. And yeah, stick around after Matt's talk for the quiz. It'll be a fun quiz on the fantastic Quizar platform. Yeah, Matt? This is in competition with Kahoot and all those other high street branded quiz platforms. It's being developed by our own Mr. F here. So stick around, we'll be using that. You need a mobile device or on your web browser, doesn't matter. We'll get on with that. But most of all, be interactive, have fun. Like I say, there's no stupid questions. We're all here to learn. So use the chat, join in and have fun, and we'll make it a great session. Quick shout out to our sponsors. As per usual, we've got the fantastic Servant, who have been supporting our user group now for pretty much the last 2 years. So huge shout out to Servant for all the support they give us. You know, great company, great group of people at the business. So huge shout out to those and thanks for their support. Likewise, we've been lucky enough to have the support of Admiral. We're headquartered down in Cardiff in South Wales over the last couple of years, and likewise NetApp as well. So big shout out to all those folks. Thanks for your support for the user group, and let's get on with the show. So on that note, Audrey, I shall hand over to you. If you're ready and you want to share your screen, we shall kick off.
All right, the battle of I am on mute and I am not has started. Thank you so much for having me here. So my name is Audrey. I am a software engineer and I am a cloud enthusiast. So I'm happy to be here. Thanks for having me around and looking forward to a nice session. So without further ado, let me just share my screen. I'll try and hide my 1,000 tabs open to the best that I can. Right. Can you see my screen at this point? All right, cool. So yeah, I'm Audrey, and as you can see, I'm not the greatest slide designer, but I'm trying my best, and hopefully, so far, I would say these are the best slides that I could come up with. Thank you. So yeah, that's about me. I'm a software engineer. I'm based in Accra, Ghana, and you can reach out to me on LinkedIn with by Audrey Mengue, and on Twitter by Lamex. Right, so now let's go to it. So today's topic is Azure Pipelines versus GitHub Actions. And how is it going to be like? I'm going to I'm going to take you through the process of creating pipelines using Azure Pipelines and also GitHub Actions. So we are going to have kind of the first set will be how to deploy, the second set, how to do it with GitHub Actions. And at the end, we'll try to see some few points that I came across that could start a good discussion. And this is just to help you understand how cool or how less cool it could be to use one of these products. So let's go. So Azure DevOps. Before we even go deep into talking about Azure pipelines, we just have to understand that it's under a service that is called Azure DevOps. So for you to be able to use the pipeline, you should have um, a little bit, you should know that you should first create an Azure DevOps organization, which is really important. It's just the process that you have to get started with. And on Azure DevOps, we don't only have pipelines, we also have Azure test plans, we also have artifacts, Azure repos, and Azure boards. It gives a huge range of services that are available for you to use so that your team will be able to deploy easily, fast, and securely applications. I just do want to point out that during my slides of this presentation, the YAML file that I have to demonstrate or that I will show you do not include tests. So it's just to make the process just a choice that I made, but a YAML file is highly customizable, or you can customize it. Yes, there it goes. So yeah, you can do that. So yeah, Azure DevOps is just a service that is provided by Microsoft that will help you to deploy, manage your repository, and get your team to deploy fast on Azure. So yeah, and you can actually use it to deploy um, on any platform that you like. So right, now that we have the Azure DevOps out of the way, and we know that that's the parent service-ish, if I may say it like that, we now want to dive deep into Azure pipelines, but we don't want to dive into it without having a little bit of definition of what it is. And yeah, so I'm just going to read it quickly. So it's to build, test, and deploy with CI/CD that works with any language platform in cloud. So you connect to your GitHub or any other provider to deploy continuously. So we are going to go through some steps and you are going to see what I mean by this definition. But yeah, this definition doesn't come from me. So it comes from Microsoft, which is the go-to source when you want to talk about a Microsoft product. So you just go to Microsoft Learn and you learn about all this, or Microsoft Docs. You know more about this. Good. So next up, we have the steps that we are going to go through in order for you to appreciate the work behind you creating a pipeline on Azure. And sorry, I have my eyes here because this is where my slides are and you are right in front of me. So I'll try to create a balance. So first step, we want to open our Azure DevOps organization after we've created one, of course. And then we want to create a project, create a pipeline, choose the source code, select a repo, and then validate permissions, configure your pipeline, edit configuration, and run pipeline. And I know this we are not talking about, we are just not yet talking about the differences. I just want you to know what you are getting into first before we talk about why you should go um, with one solution or another. And I'm just encouraging you to just have an open mind and at the end of the day, when we start at the end of the slides, when we start the discussion, you can come up with your own conclusion, like which one should you go for? I mean, even though we discuss it together. So the first step, you create an organization. You log into your Microsoft, your Azure portal, so portal.azure.com, and then you sign in. You create an organization. I already have organizations. That's why you see the slides here. But this is how it's supposed to appear. After creating it, then you create a project. And yeah, you can choose. There are different projects that you can create. If you want, you can create a new one here, just clicking the button and you create a new project. And I have a project already, so I'm kind of good to go. So I'm just going to use this one. So the next step, when you get to Azure Pipelines, when you log into the project, you see the services that you can use on this project. So you have the pipelines, the repo, the board, and the test plan, the artifact. So we are not focusing on the rest right now. So we are mostly focusing on um, the pipelines itself. You can have environments, you can have releases, you can have libraries, tasks groups, deployment groups. And I'm just throwing it at you right now so that you know the possibilities that are here. So you can create particular environments for you, for your deployments. You can have releases. You can set up release environments. You can have libraries where you actually store your keys that you can have you share among different environments. You can have tasks groups. So if you've defined a certain group where you want to run certain tasks, you can just group them and yeah, and they will run for this. You can have a set of tasks for a particular group, and deployment group if you want to have to deploy a certain what you're working on different set of virtual machines or wherever it is that you want to deploy, and if you've logically grouped them, this is where you are going to work on it. But we are focusing on the pipeline on its own, just the pipeline. So now, in a new pipeline, you can create a new pipeline. I have already some set of pipelines right now, and yeah, 3 of them. You can have as many as you want. And to do that, you can just click on the new button. When you click on the new button, you will land on a page where you will be asked to choose where your source code is. You can go with the classic editor. This one, you can create your own YAML file, but I usually go with GitHub because it gives me a predefined YAML file that I can actually customize to my own needs. Next up, we have the repositories. When you select the repositories, once you choose the platform where your source code is, you have access to the repositories hosted there. I don't know about other platforms. I'm just using GitHub. I've been using GitHub forever. So yeah, this is basically all I know. I'm always ready to learn something new, of course. So you select your repo. When you select your repo, you'll be redirected to a repository to validate to your GitHub to validate permissions, enter your password. After that, you land on this page where you have Azure DevOps, Azure Pipelines integrated. So with this, it's just a presentation screen, nothing, but the part that we are actually interested in is this part, which is the repositories that you want to select. So you want to select only this one if that's what you want, but you can have more repositories and you don't really want to go to the danger zone. Yeah, so when you pick the repo, you can actually approve and install your pipeline. Good, so next, we will configure after we've granted access to Azure pipelines. We'll just configure our pipelines, and from here we can choose packages, should I call them? And yeah, and these are just sets of YAML files that are basic, like basic YAML file configuration that you already have, and you can feel free to actually modify it. You can modify them and get them to work the way you want. So this is the basic pipeline file that you get. And I do want to point out something very interesting here. The version specification, be mindful of that. So I believe in these slides here. So you have here, it's kind of an old version of the node. Yeah, an old version of nodes that they are using. So you just have to update that part. Very, very important. Yeah, very, very important. I'm saying that because it gave me a lot of problems when I was trying to deploy on it. Yeah. I invite you to actually go through this. You'll learn a lot when you go through hard times. Lastly, I mean, not lastly, so now you have to configure this YAML file because the basic configuration might not run the way you want. And okay, the reason why we are even having this discussion, I'm not a DevOps engineer, I'm not a cloud engineer, I'm a software engineer. And sometimes when we work at a startup, you can become a a cloud engineer. You can become a DevOps engineer. Like you will be changing hats from time to time. And the reason why I wanted to actually share this with everybody that I know, it's a reality. I didn't know all this until I was put on the spot that, hey, we need this to be done. And the DevOps team was actually not ready with the pipeline just yet. Now they are, but before it wasn't the case. We had to do this all by ourselves and we learned like tremendous amount of learning. But at the end of the day, we were able to pull it up. And that's the reason why I'm here, because I'm like, you don't actually need to be able to you don't need to know everything about a certain technology. You get to know more if you're interested, but if something gets the job done, just learn it quick. And if in the future there's a need for you to actually become a DevOps engineer, why not? You gain knowledge. Yeah, so you should be able to modify this, and this YAML file has changed so that it can allow us to deploy our code to run our builds. Anytime we make changes on our GitHub repositories, they go through that pipeline process and they reflect to our application, which is hosted. So yeah. Next up, once it is done, you will have a running process. This page shows the jobs, like things that are happening behind the scenes. And behind the scenes, a lot is happening. And a lot can get broken. For instance, next. So in our jobs page, in our YAML file, we define a set of jobs that we were supposed to actually go through. And for an interesting reason, it's not always running smoothly. And that is why I'm actually sharing this slide instead of the one that works perfectly. Because it took me, I would say, a lot of tries before getting to the stage where everything was just green, 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 and you are all happy and you are going home. And on your next Scrum, next morning doing the Scrum, you are happily giving an update on this, and your 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 lead is happy about your progress, right? People may think that yeah, it's that easy, like it is that easy, but it is not. So that's why I really wanted to share the part that didn't work out, because it is actually not going to work out that easily. And that is it. So right now we have an idea on about how to set up a pipeline using Azure pipelines. We've gone through the process, we've seen how it is done. Now, next up, I just want to take I hope your mind will still have this, you still have it in mind, because we are going to come back for the discussion, of course. And now, going to do something else. Oh, I also wanted to show you that whenever it doesn't work, you can come back to this, view the raw logs, where you have detailed logs of why your pipeline, your run failed, your jobs failed, at which stage and why. basically. So you have a full log of it, and it's going to open in on another page. So it's going to be pretty detailed, and hopefully will help you. Okay, next, GitHub. So fine, we spoke about Azure DevOps, and now we kind of know that, okay, Azure DevOps has a lot of services and one of them is pipelines, and we know how it works a little bit. And yeah, I might want to learn more about it. I hope you would. Yeah, I hope so. So the first thing first, GitHub. The second thing that we are going to tackle right now is GitHub. GitHub is, I would also say, the parent service. If I can say, I know I may be very inspired, but I just believe that science, when you explain scientific, I would say you should just be open-minded about your own experience. I stand corrected, of course, but this is my own experience and this is how I understand these things. So now you have the parent um, service, and then you have other services under it. And one of them is GitHub Actions. I hope I'm not confusing you. And yep, GitHub Actions is also, I'd say, a little bit like Azure Pipelines. If I want to be even further honest, they do the same things. Like they're helping you to build CI/CDs, integrate test, deployment, uh, tracking, all that good stuff all together. One place. That is what they do. And at this point, you might be like, oh, so what is actually the difference? Oh, there is. We're coming. We're coming. Now, next, the steps. We can already see the difference in the steps. I don't know, but we are going to have the discussion later on. So the steps, you first log into GitHub and you choose a repo, you click on actions, and you add this home script into your package.json that you go back to your code. Then you install a GitHub Pages package. That is where we are going to host our website on. We deploy it on GitHub Pages. Now, when you generate and then next you generate tokens, and then you create secrets, uh, then you update the YAML file with deployment steps, and then you set your GitHub pages to route to be on the GitHub pages, and then confirm your successful deployment. Oops, I have a typo. Thank God it's just text. It's not coding. We are now I'm going to show you how it goes. Um, First off, you log in. Let me see the time. That's good. I'm good. So first time you log into GitHub and you choose a repo. We are on it. Let me just say, this is my GitHub and this is my repo. You can also follow me there if you want to. So yeah, then you log in, you choose a repo. After that, you click on action. Simple. You click on actions. When you click on actions, then you have a different set of flows, and that will be suggested to you for you to use. So you can use the one that is recommended for me is the Node.js, build and test Node.js project with NPM. And then you have different flows. And I think the best one for me, given that I'm running a JavaScript application, it's actually the Node.js, and I'll take the first one because I want my life to be simple. Again, this presentation is just to not scare you, to just tell you that even if you don't have all this background in cloud computing and in DevOps, you can try these products. They are quite cool. It's not the wizard for you to get started with. You can actually things are there to help you out with. So next step, after you created it, you have to confirm the directory. Like you have to confirm that the YAML file has been actually created. I have another typo. This is interesting. So yes, the YAML file has been created, the basic one. And here, the interesting parts, you actually have node versions. that are already predefined. That are not old. That are, yeah, I think some people may use the version 16. I use the 18 one. Yeah. But yeah, here already we have a difference here when it comes to us setting up the pipeline, because our YAML file that defines the steps that we take is actually pretty simple and yeah, pretty easy, cool to understand. And then you go back to your text editor where you have your home, where you add this home script, should I say, to your JSON file. And then when you add it, this is supposed to tell GitHub that, okay, this is where we are getting, this is the home page, this is where we are getting the uh, uh, where we are deploy the page that we are going to show when the deployment is done. Next, you go back to you still remain on your local machine and you run this to install the GitHub pages. And then of course you go ahead and um, you install the GitHub pages, and then you have to run the command to be able to enable it. I should say enable it. Okay, good. So now, and then you go back to your GitHub and then you generate personal tokens so that you securely, would I say securely deploy your application? Yeah. And the next step, you update your file, your YAML file with the necessary information that you needed to add. So your username, your email, your the deployment access keys. After that, you set up your Git page to be on the root to be on GitHub pages, I think. Okay. All right. So there is supposed to be another slide here, but yeah, you are supposed to go back on GitHub, and then when you go to the GitHub pages, the root should be on GitHub dash pages. That's where it's supposed to be. Sorry for the mixing of the slides. I hope you forgive me. So last, hopefully, is that you have to confirm that your deployment is successful. So you have the workflows that are here. You can see this time around, I'm showing you something that is cool, something that is actually working. It didn't fail us, but yeah. Yeah. And you have all the information that you need over there to be able to see. You have here the CI that has been uh, the commit that we've made and how the continuous integration has been triggered, and then it's actually how will I say it, updating. And then you have the GitHub pages build, and then the flow is just updating the pages, and we have our changes reflecting. So that's it. That should be it. Yeah, that should be it. That's it for both when you want to deploy your application using GitHub pages and GitHub Actions. Before we get into the discussion, is there any question? Or I should just continue? John?
I can't see anything in the chat yet. No, that's great so far, Audrey. Yeah, I think we jump into the discussion. Cool.
Good. Good. Thanks. Good. So now I've just enumerated three points for this, but I just want us to go further in details as a group to have a discussion around it, because trust me, even though I'm the one seated here doing this presentation and I've experienced it to some certain level, I'm still also very I don't really know if there is an issue with me. I mean, which one should I go with, or should I go for first? It's yeah. So okay, so there is another typo. Okay, it's not a typo actually. It's source code and open source. Good, good. So now rating both, and I stand corrected. I am not an expert. I am sure there are DevOps experts here. I'm sure there are cloud experts here, and I would love to learn from them. I would love to, but these are my thoughts based on my research, based on my interactions. So yeah, so when it comes to the learning curve, I'd say it's moderate when it comes to Azure pipelines because there's a lot that you actually have to learn about. I'm not saying that you have to go deep into um, what Azure DevOps does with other services like boards or artifacts or anything else. No, but it's just like, there is a lot on the platform. There's just a lot. When you land on there, and you're like on the sidebar, so many stuff happening, it can make it a bit tough. So now that is what I think, that it's moderate. It's not that difficult. I wouldn't also say it's that easy. I'll just say it's moderate. And GitHub Actions, fairly easy to me because all I had to do during this process, I didn't actually even care about anything else. I just chose the flow that I wanted and I customized it. If I look, I can go to the marketplace. There's actually a marketplace where you can actually search for specific flows that you want to work with or implement, and then you choose them. And all you will have to do is to work on your YAML file or define this flow in details. But so far, it's kind of cool. There's not much going on there. You just choose a flow that you like. You choose a repository, you set up GitHub pages, or you set up some flows actually allow you to even deploy it on other platforms. And it's all depend on you. Like, it's all up to you. So source code. Well, Azure Pipelines is better. Why would I say so? Because as you could see, we had we could choose the code, the source code from many platforms. I don't know if I can quickly go back to that slide. There you go. So you have Azure repos themselves. You can even choose your source code from Azure repo, Bitbucket, other Git or generic repositories, submission, centralized version control by Apache. Like, you have the choice over there. So you have like a lot of choice when it comes to where your source code resides. And again, I stand corrected, but so far, when it comes to GitHub Actions, I just saw that you could choose your code base or your source code right from GitHub. Now, the second one is open source. I think both are fairly okay when it comes to open source so far. Yeah. And will I even say when it comes to the price, actually? So yeah, they are fairly okay. That is to me. And I've not come to a place where whatever source code that you have, even if it is open source, they all provide the support for you. You can run your pipelines and you can deploy them, and you can work with your open source code on both platforms. That is okay. Yeah. So that was uh, that was it. But thank God, yay.
Was
I don't know if we've lost Audrey there. Audrey, you still there? Yeah,
If you
there's
have any
movement.
questions. Hello.
You're back with us now. You froze there for a second, Audrey, at the end. No, that was fantastic.
Sorry.
Thanks, Al. I was going to comment. I think one of the first times I used Azure DevOps, I used a classic editor, which, I mean, for me, I'm not a software developer, but I found that really a lot easier. I'm not too sure. I don't know if anybody knows why Microsoft had kind of deprecated that classic editor, because it was very much that, drag and drop almost to create your YAML behind the scenes.
the answer behind that is about who controls it.
Right.
When you use the classic editor, where it's saved is controlled as part of Azure DevOps.
Yeah. Yeah. Okay.
You get it saved and it's managed as part of the team within Azure DevOps. When you
Yeah.
use YAML and you use all the pipeline stuff, they're stored as part of the repos themselves.
Yeah. Yeah. I get that. Yeah.
They sit alongside your code and they exist with your code. Whereas what you tended to find was that organizations tended to have separate teams that would manage the pipelines.
Mm.
And in those scenarios, actually, the classic pipeline works really well because it's now completely decoupled from your code and it's separated. It's somewhere else. So, yeah.
Yeah. I mean, for something like
was a
Thank
good
you.
one.
So again,
Go on.
Really good. I'm learning.
That was a good information, Matthew. Actually, it was.
Yeah.
So I think the
Thanks.
other thing I will point out is the thing that I really like about GitHub Actions, because I'm a big fan of GitHub Actions, is that they're more than CI/CD. So with Azure DevOps Pipelines, if you create a pipeline, you're going to be triggered based on some change that's happening to a repo or
Yeah.
on a schedule or a webhook, typically, right? They're your three options. With GitHub Actions, the triggers they're much more varied in that you could be triggered on, you could have a pipeline that runs when a issue is created or a comment's added to a pull request or a page is added to a wiki or an item is moved from one column to another in a project. So you can have pipelines that run off the back of all those things. And then you couple that with the, was it the Octa script that's part of GitHub Actions? So within your GitHub Actions, you can use this thing called Octa script, OctaKit, I think it's called, which then gives you access to the issue that you were looking at, or the pull request that it was triggered on, or the repo that you're in. So you can actually then start, like being more kind of creative about what you do with those actions. And the best thing to look at this with is if you do any of the learning paths on GitHub for GitHub Actions. The way that they work is that they say, here's a repo, go clone this repo. And the minute you do that, the first thing that gets created is this issue that appears in your repo, right? And then every time you make a change to it, or you create the action that it needs, or you create the YAML file, in the background, it then triggers another GitHub action to then move you on to the next step of the tutorial. So all of your tutorial is done in the context of your repo and using GitHub Actions. And it's very cool, very, very cool to play with. It feels like you've got a bot watching you, like sitting over your shoulder, just watching you complete all these tasks, but it's actually using GitHub Actions behind the scene to drive all this.
I think before coming to this meeting, I was extremely biased into the Azure DevOps and a tough position also, right? Because from Microsoft's perspective, they have now two products which is practically doing the same thing. One is GitHub Actions.
Yeah.
At the same time, there is a pipeline. Which one do we go with, or which one are they planning to shelf? Is there an established roadmap? That is the more curious part. Which one do we take actually a little more serious than the other one?
So, as the official Microsoft person on the call, because
go on.
For those that don't know me, I'm going to be introducing myself in a minute anyway for my talk. But I'm what's called a digital and app innovation cloud solution architect at Microsoft, which means I spend a lot of time talking with customers about developer technologies, of which DevOps and GitHub are two of them. Right. So I actually spend a lot of time talking about both. And the reality is that both are staying around. Right. And the reason I can say that confidently is that Microsoft have a ton of people inside Microsoft who are using Azure DevOps. And actually, the process of moving those teams off onto GitHub, when the GitHub doesn't have the things that they need just yet, means it's not going to go away anytime soon, right? The other part is that one of the big reasons behind that is that Azure DevOps is very much more skewed towards the enterprise, right? GitHub is skewed towards this idea of inner sourcing and open source. You know,
Open source. Yeah.
it's this very simple model of, you know, I want lots of people in my organization to contribute. What it doesn't do is things like, you know, if you go and get a GitHub Enterprise Cloud, your GitHubs, your repos are going to be hosted in North America, right? Which for some enterprises is an absolute no-no. Right. The other option is you can host it on-prem and you can spin up your own VMs to do all that and host that in your own subscription, and you can absolutely do that, and that works fine. Azure DevOps has these options of, you know, you can deploy to wherever there is effectively an Azure region, so you can have your code and your resources stored in that region. So, like, the reality is they're both good. They're both fantastic projects. They've both got engineering effort going into them now. So there's both work happening on both products. You've got to find the one that works for you. And actually, what I'm seeing with a lot of customers is it isn't an either or anymore. It's maybe a both, right? Why not have so your repos stored in GitHub, because the thing that GitHub does really well in some cases is the, you know, the advanced security stuff and all that kind of gubbins that comes along with GitHub, but then use Azure Pipelines to drive all that. Or use Azure Boards, which is a far superior product to something like GitHub Issues and GitHub Projects, because it's trying to target different audiences and give you much more control. Like, there isn't an equivalent for something like test plans in GitHub. So find the thing that works for you, find the thing that works for your organization. I hadn't intended to come on here and talk I was doing a pipeline tonight, but I'm happy to. I could do this all night. I'm quite happy to talk this stuff all night. So
yeah, I mean, it's a discussion. Yeah,
absolutely. It's find something that works for you. You know, I think they're both great. But like, I've made a large career of doing and working in Azure DevOps and GitHub. So, you know, I think they're both fine and they're both great. I use them for different things. So, you know, I pick and choose depending on the project. I tend to find if I'm doing private stuff that I want to collaborate with people in the same organization, I'll use Azure DevOps, because I can lock it down to particular, like, AD users. If I'm doing collaboration on open source stuff, I'll use GitHub.
Yeah.
Yeah, I mean,
I think, yeah, that's the main thing. To me, that's the main way I understood it. So if you want to work, if you are working in an organization, let's just say you have these shared keys that you have in the library, and you have the possibility to share this pipeline flow with a lot of groups in your organization, like deploying to groups that belong to this particular company that is not open to the outside world, then you can actually use Azure DevOps. It's more centered to company-like environment, enterprise-like environment. Yeah.
I will say,
to
I
me,
mean, there's this mentality, this thing called inner sourcing, which is something that GitHub is really, really strong on. And this is the idea of what you want is anyone from any part of your organization to be able to collaborate on a project. Like, you should be able to have a pull request coming from a completely unrelated team to support your project. And that's what GitHub does really, really well. Azure DevOps can do it, but it's not skewed towards that. It's skewed towards a much more traditional, you know, we've come from TFS and source safe and all those kind of route all the way through. And I did mention the source safe word, and I do apologize to all those that still have nightmares because of that. You know, it's to go all the way through from those kind of very traditional, this is a development house, we've got separate teams that are going off and doing stuff, and they're working in agile methodologies or Kanban or whichever they want to go, and they're moving through from, you know, different environments and different production rather than using a pull request model.
Cool.
well,
There we go.
cool. Thanks.
No, Audrey, no, thanks so much. That was an amazing talk. I think it's, you know, it's certainly a conversation point, like you pointed out there. So if everybody wants to show their appreciation, either come off mute and round of applause or use the reactions. But you've got to use the reactions, Matt.
Woo, thank you very much.
I want to applaud
Thank
properly.
you.
It deserves an applaud. So.
No, that was awesome.
Thank you.
Thanks for your time, Audrey. And yeah, feel free to stick around now for Matt's talk and of course the quiz. You can join in the quiz as well with us. But cool. On that note, then I'll give you the introduction, Mr. Fortunka.
Again.
Over to you. Over to our very own Matt Fortunka to talk about Azure Container Apps.
Yes, let me just share my screen and then we're there. There we go. Everyone should be able to see that.
Yeah, got you.
Now onto the topic that I intended to talk about today. So, hello everyone. So, as I've sort of introduced already, I'm what's called a digital and app innovation cloud solution architect. And that basically means I spend a lot of time playing with dev technologies and things like Azure DevOps. I spend a lot of time talking with things like what's that little thing there? Talking with things like Visual Studio Code, or those kind of technologies like Blazor, Maui, all those kind of wonderful things. So I get to spend a lot of time playing with the cool stuff. I think is probably the best way of describing it. Now, I think it's fair to say that over the last few years, containers have kind of established themselves as kind of a de facto standard for microservice development. And they offer massive benefits in kind of optimization of compute resources and new patterns for creating software, and particularly when they're coupled with things like orchestrators like Kubernetes. But let's not kid ourselves. Running Kubernetes clusters can be hard. Essentially, you are running a collection of VMs, each of which needs to be patched, updated, watered, fed, etc. Now, AKS simplifies some of this, but you're essentially still dealing with what we class as an IaaS platform. You're still dealing with VMs under the hood. Animations in it. What's that? Now, for those unfamiliar with Kubernetes, and if you're brave enough to deploy a cluster from scratch, here's what you're going to need. So there's two types. Let's skip over these. We don't need either. There we go. There's two types of VM pools required. There's what's called the control plane, and you need to have one of these. And this handles what's called the API server. So if you've ever done any Kubernetes before, you'll know there's a tool called kubectl or kubectl or kubectl, depends on how you want to pronounce it. And this is basically a wrapper around the API that's exposed through Kubernetes. And when you apply a YAML file to your Kubernetes cluster through kubectl, it's writing the configuration to a data store under the hood, and this is this thing called etcd. So this is basically a set of the state that you want to achieve in your cluster. And then there's this scheduler that then looks for changes and applies them. Right. So that's all kind of the Kubernetes management stuff that's going on. Now the other side, there's these things called agent nodes, and these are arranged into node pools, and each node pool has multiple VMs or nodes. And this is the bit where your code runs. And your code is divided up into deployments and then divided into replica sets and then into pods and then into containers. And each node contains a kubelet component to handle the requests from the scheduler, so that the scheduler then sends out requests to each node to deploy the stuff that it needs to. And then you've got a thing on there called kubeproxy, which handles some of the networking requests that are coming in and out of the cluster. Now, if you deploy all of this yourself, including your control plane, you are responsible for the maintenance and the updates of all those components. Skip over these a bit. Now, the difference between this and like a managed platform like Azure Kubernetes Service is that the control plane, so all of the API server, the etcd, the scheduler, those kind of bits, they're no longer your responsibility. The platform holder takes care of the updates and the scaling and all the patching that needs to happen for those machines, and you just need to focus then on the machines, the VMs that drive your business value. So basically, where you're hosting your microservices. Downside to this is that you still need to manage those node pools. You've still got to manage those VMs. Now, if you can overlook the fact you're dealing with VMs, there's a lot of advantages to running on a managed Kubernetes platform like AKS. So there are tight integrations with the Azure platform is probably the biggest one there. which means you get native support for things like Key Vault and Azure Policy. And it makes running that cluster easier and managing who can deploy what to that cluster. But ultimately, it still comes back to this problem of you still need to think about the servers. So enter Azure Container Apps. This is our latest offering in the managed Kubernetes space on Azure. Container Apps can be thought as an opinionated container PaaS platform that just so happens to run on Kubernetes. Now, there's a lot to take in there, so let's break it down a little bit. It's opinionated in that it's built on specific versions of cloud native projects, specifically Dapper, Cada, and Envoy. We're going to be talking a bit more about those later, so I'm not going to go into too much detail now. Now, if you want to be on the bleeding edge with these, or you require other frameworks or things like service meshes, then Container Apps is probably not going to be for you, right? It's opinionated in that there are specific versions, and we will constantly be making sure that those versions are kept up to date. But you are going to not have any control over what versions get installed. So if you don't want to worry about installing or managing these installs for these services, then happy days. Now, I also said it's a PaaS solution, and PaaS traditionally means no servers, or at least no VMs, should we say. It also means elastic compute, so you pay for what you use. And then lastly, I said that it runs on Kubernetes. And what that means in practice is that under the hood, Azure Container Apps is an AKS cluster. But in the same way as if you deploy a regular AKS cluster, you don't get access to the control plane. You don't get to look at etcd, and you don't get to look at the scheduler and tinker with that. With Azure Container Apps, you don't get direct access to the kubectl, to basically your AKS cluster at all. So there's no kubectl. So all of your interactions are through the tooling that's provided on top, basically the standard Azure tooling. So that whether that's ARM templates, REST API, the Azure CLI, or the portal. So on the flip side, Azure Container Apps isn't opinionated about the language you use to write your containers. And this is in exactly the same way as Kubernetes. You can still create containers that are only accessible within the cluster. You can still create containers that are exposed publicly. And you can have containers that run background jobs or respond to events. Azure Container Apps supports scale to 0, making it more in line with servers platforms like Azure Functions. And through technologies like Envoy, we can ensure that all of your ingress and service-to-service traffic is encrypted. Now, there are enterprise features being rolled out, like support for VNet integration, which means that your containers can access resources on your network. So what does this look like in practice? So let's go through the terminology of a container app. So everything starts with a container app environment. This is a secure boundary for a group of container apps. Container apps in the same environment are deployed in the same virtual network, if you're using that, and write logs to the same log analytics workspace. You can think of your container apps environment as being analogous to your Kubernetes cluster. A single container app represents a microservice, and that's composed of pods made up of one or more containers. Now, Azure Container Apps provides the foundation for deploying microservices featuring independent scaling, versioning, and upgrades for a container app. You can do service discovery, and we'll come on to a bit later, the native Dapper integration. Now, containers in Azure Container Apps can use any runtime, programming language, or development stack of your choice. Essentially, you're going to create a Docker container at the end of this. Now, currently, only Linux-based container images can be used. That's a bit of a limitation at the moment. You can define multiple containers in a single container app, and they will be scaled as a group. Groups of containers are known as pods, so the containers in a pod share hard disk and network resources and experience the same application life life cycle, meaning if one shuts down, the pod shuts down. So one of the concepts we have in Container Apps is a thing called a revision. And a revision is described as an immutable snapshot of a container. The best way to think about revisions is if you've ever done anything with app service and you've used the idea of deployment slots where you can have multiple parallel running versions of an application, then revisions is the closest analogy we've got to that. You can have up to 100 revisions for a single container app at any one point in time, but you're not charged for inactive revisions. So if the thing isn't running, if the thing isn't taking traffic, you're not paying for it. They're really useful, and we're going to show a demo of this in a minute, where you enable ingress to make your container app accessible via HTTP. They're great when you want to direct traffic from one snapshot of your container app to the next, which means you can do like traffic direction strategies like A/B testing or blue-green deployment. And of course, all of this is supported from all of the various CI/CD platforms, and you can do from GitHub Actions. So we've got an example there of GitHub Actions, but actually works just as well with Azure DevOps as well. So these are the scenarios we see being most useful for Azure Container Apps. And the most obvious one, and the one place where people start, is with just deploying APIs. Right, use it as an API hosting platform. And actually, it's a pretty analogous to Azure Functions actually as well. Is the thing that majority of people start with when they start using Azure Functions is by deploying HTTP endpoints, and that's great because it does that really well, and so does Container Apps. Where Container Apps starts to shine is where you start looking at the non-HTTP based triggers. So being able to do things like scaling off queues or scaling off one of the CADA supported scalers. So we're also seeing it as a platform for hosting background processing applications, like handling those event-driven processing, and then running effectively the orchestrations of multiple services. So when an API comes in and an API gets called, it might hand that request off to 4 or 5 different microservices before returning something back. So let's do a quick demo of this idea of revisions. Now, in the interests of my own sanity, I've recorded these as videos, but I'm going to talk over them live because there's some elements of this that take time. So I've been able to speed up parts of the video just to make it a little bit easier for everyone. So I'm going to run this now. So what you're seeing here is a, come on, play. What you're seeing here is a set of resources that have been deployed, right? So I've got the standard things you would expect. So I've got a log analytics workspace. I've got app insights. I've got a managed identity there. And I've got an Azure Container Registry. And the managed identity is so that the container apps, when they get deployed, can authenticate to my Azure Container Registry, so they can pull the resources from it. We've also got a storage account in there, more of which we'll come onto that later because we're going to use that for one of the demos. So yeah, there we go. And you can see actually that this, what I've done with this managed identity is I've granted it rights, and it's what's called ACR pull rights to that container registry, so that when we need to go and get an image, we can. Now, at the heart of it is this thing called the Container Apps environment, and this, like I said, is my container shell. Now, what we're going to do is we're going to create a new simple API, .NET Simple API application, and I'm going to load that up in VS Code. Now, I'm using the minimal API stuff here in .NET, which means that actually that's the entire sum total of my application, which is really nice. Now I'm going to add a single root on here, and what I'm basically going to do is to say, when you hit the root of this application, then just return a string. So I'm just going to return some text. Okay, so return container apps can do HTTP. There we go. So we're starting very, very simple. And then we're going to test this, and you'll see there's a glitch here where I correct a spelling mistake that was in there. We're going to run that, and you'll see that it exposes it. So when I run it locally, I can go to this particular endpoint, And you can just about see, if I zoom in on that, I chopped the top of these for some reason, that it can do HTTP. So this is just running locally at the moment. Now, the next thing I'm going to need to do now is to build my Docker file. So I'm going to use the built-in functionality within VS Code to add a Docker file, and it tells me what I want to do. So I'm going to do a .NET one just because it's what I'm using, running on Linux, what the port is, and it's going to generate that thing, right? So now I'm going to do a Docker build, and instead of doing Docker build, which is the command that would usually build your image locally, I'm using a command called AZACR build. And what this does is it uses the Azure Container Registry. I've just noticed my camera's frozen. I'm going to spin that up again. So this uses the Azure Container Registry to build my image and then push it up to the registry itself. Back in there. So you'll see in a minute, as soon as that, this should have been sped up more than that. Come on, accelerate. That paused. No. Come on. Note to self, speed this bit up more. There we go. The build's done now. That has been sped up quite a lot. And then the end result of this is that we will now have a particular tagged version of my container and my application running in my container registry, which you can see here. So if I go into my repositories, you'll see I've built this very, very simple API, pushed it up into Azure, and there's my V1. Okay, so that's all done with that one AZACR build command. Okay, so now I need to get that into an Azure Container App, and the way I'm going to do that is using a bicep file. And I'm going to gloss over a lot of this because there's a lot of guff that goes on in this, and actually you can do all this in the portal as well. And I just happen to choose to do this in Bicep because I can then reuse it for other people. So I've got a whole set of predefined variables that I'm setting up, and then I've got some references to existing resources. So I'm basically saying there's already an Azure Container Registry deployed, there's an Azure Container Apps environment deployed, and there's a managed identity. Get me a reference to those things so I can use their name and I can use their IDs later on in the file. So now I'm going to build my Azure Container App, and it's a very simple app. It's a very simple command. So I'm just going to use bicep here, and it's Microsoft.app. If you were using any of the previews of this, these all changed last minute. So it used to be in Microsoft.web, and it used to be in the same area as kind of web apps and app service and things like that. So, but it's now moved to its own thing. So I'm giving it a name. I'm telling it where my location is. Skip over a lot of this, and then we're giving it the identity. And this is the identity it's going to use to access the Azure Container Registry. And we're going to use the one that I've already got defined. So I'm saying basically, let's go and grab my managed identity. There we go. I'm going to add an item here, which is going to be my managed identity.id. And there's no additional parameters for it. So that's the identity it's going to use to access that container registry, which means I don't have to mess around with providing passwords and things like that into this script. And then we're going to add some properties on it. And we're going to tell it which Azure Container Apps environment I'm going to be using. So there we go. I'm going to use the predefined one that I defined above. And then we're going to provide a configuration. And the configuration is going to say how many revisions I want. And in this case, you can either choose to have multiple revisions active at the same time, or only ever one revision active at a single point. We're going to make sure this is accessible publicly. So we're going to add an ingress on there, which is going to be externally facing. I'm going to tell it what port I'm running on, which is the port that my app runs on by default. And we're going to come back to traffic in a minute, because that's going to be more important when we talk about revisions. Right now, all you need to know is that I'm saying this is the version that I'm deploying up, and I want all of the traffic to go to this particular revision. So I can give it the name of the container image, the app itself, and then it'll be my V1. And then lastly, I'm going to say what weight it is, which is that I'm going to take all of the traffic. Now, the one thing I haven't done yet is to say which container I should be using. So the last bit that comes in here, I think it's the last bit. Oh yeah, so I'm going to tell it which container registry I want to use. Let me give it some details there. Let me tell it which managed identity it should use to log in. And now we tell it which container we need. So now we're going to say, this is the template of the thing that I'm going to deploy. This is my microservice definition. These are the containers I'm going to use. And in this case, I will go and basically grab the image details from my container registry. So I know which Azure Container Registry I'm on. I know the image name because that's the one I've provided as a parameter. And I know I want to grab the V1 of that image. We'll give it a name. Skip over this, blah, 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 blah. And then lastly, the last thing I need to do is provide it with a revision suffix. By default, if you don't do this, it'll automatically generate you one. But this revision suffix gives you more control over how you identify which particular revision you're currently working with. So yeah, just quick summary. We've got our ingress controller. We've got the template that we're going to use. We've got our registry definition. And then we can deploy. And we're just going to deploy using the standard AZ deployment group create command on the Azure CLI. So this is the bit I sped up as well, hopefully. So we tell it which resource group I want to look in, and then we're going to deploy this. I'm going to clear the screen, and then I'm going to deploy it. There you go. Because I'm in the wrong folder. There we go. And we'll deploy. And with any luck, this usually takes anything up to about 10 seconds. So I think it's been massively accelerated here. There we go. Just to cut down on this. And what you'll see now is that I've now got my container app deployed. And there it is, simple API. And we can go in and see, have a look at our revisions that we've got deployed. I've got a URL for it. And now I've got a revision management and it says it's been provisioned. It's the label V1 and it's taking 100% of my traffic. Now, what that means now is if I click on that URL that's provided for my container app, it's serving up that same message that we saw earlier. So let's go and now deploy up a V2 of that. And our V2 is going to be very similar to what we had before. It's just going to say that, yes, we can do revisions. So I'm going to create a V2, build and deploy that up. That skips over very, very quickly. And we're going to push that now up to the container registry. So if I go back to my container registry, we should see I've now got a V1 and a V2 of that app running. And again, you could do all this through Azure DevOps Pipelines or through GitHub Actions. You can orchestrate all of this yourself. Now we're going to make a slight change to our bicep file to deploy up our V2. We're going to change our revision suffix so that we're now looking at V2. The image we're going to be deploying now is also going to be our V2, and we're going to give it a new name. But for our traffic splitting, we're going to say, well, let's just deploy both. So I know I've already got V1 up and running. Let's add a copy of that, deploy V2, and then let's set this to 50% on both. Now, what that means is that that public endpoint I have will decide whether or not it routes to the V1 or the V2, and it'll effectively do it on a round robin. So effectively, it's not quite round robin, it's whatever algorithm it works under the hood. So we've now deployed that up. Going to do it same thing again. And you should see now, if we refresh here, I've now got V1 and V2. And we can go on to my URL. And you will see I've got that. And as I hit refresh, you see it's alternating between the two. So it's now, that single endpoint is now serving up both. And that's useful, but actually, what if you want to target a specific version that you've got deployed? Well, you get a URL for each of them. So I've got a V1 endpoint now, and I've also got a V2 endpoint now that I can target those specific versions. So if I want to go and see what my V2 currently looks like, I can do that. But if I want to use my Ingress controller to work out like how I do traffic splitting and A/B testing and things like that, I absolutely can do that. So let's just move on a minute. So let's shift gears and let's talk a little bit about the process of developing containers. And we'll start with the positive. Right? By developing small constrained functionality microservices, you're able to make the most efficient use of the hardware they run on. And the reason it does that is because the orchestrator is able to place your code in the place that would basically make the most use of the hardware that's running on those nodes. Containers and by extension microservices make simple a load of kind of the network headaches of the past. So in a container orchestrated environment, everything is in a closed system and your networking is only going to happen within inside that contained environment unless you explicitly expose it to the outside world. So in essence, containers let you focus on developing your applications without the headaches of deployment and infrastructure. Now, I will caveat that and say there are a whole new set of headaches that come with it, but we'll come on to those in a minute. Now, lastly, containers let you pick the best language for the job, right? And this is becoming more and more important. I'm seeing this with more and more customers where they are seeing the benefits of using something like Go if you're doing really lightweight microservice APIs because it's a language that was developed with those platforms in mind. Or something like F# or something like Node. Like if you've got teams that are capable of developing these languages, then let them develop, and then let the Docker be the binding kind of commonality between everything. Now, with this flexibility comes a challenge around working with like platform or external features. Like different languages have different levels of maturity when it comes to SDKs. Like the Azure platform services are a good example, right? If you want to use something like Key Vault, then the support you're going to get for .NET languages or Node.js or Python really good. Like those SDKs are great. But things like Golang or Rust or whatever and language of the moment is, it differs depending on the service. Like it depends on the effort that's being put into it because we have to prioritize that resource somewhere. And I'd also ask, like, how portable is your code between different implementations? Right? If I want to write to a key value store in .NET, I'm going to need to learn one SDK for Redis, right? Or I might need to learn another one for blob storage or another one for SQL. Like, what it means is that my code inevitably becomes opinionated and tied to a particular underlying platform implementation. And that's where Dapper comes in. Dapper is an open source project supported on Container Apps. It provides a portable, event-driven runtime for building distributed applications across cloud and edge. In practice, it provides answers to the following questions, and this is a subset of them. Like, how do I create event-driven apps which reliably send events from one service to another? How do I handle connection failures and build resiliency into my application? How do I prevent committing to a technology early and have the flexibility to swap out an alternative based on project or environment changes? How do I secure communication between services? How do I make use of services like gRPC? Like my application ideally shouldn't care about gRPC or HTTP. It should just write what it knows and then let something else handle that. And that's what Dapper does. So Dapper exists as what's called a sidecar container that gets deployed alongside your container app. And all of the Dapper functionality can be accessed using a local HTTP or gRPC call. Now, there are SDKs for helping you with Dapper, but essentially they are wrappers around producing HTTP or gRPC calls. This is not an Azure thing. That means you can deploy the Dapper runtime on any of the cloud providers' Kubernetes offerings. Now, amongst the services offered by Dapper are things like service-to-service invocation. So that handles service discovery and like which protocol should be used. So in the example of what I just gave earlier, you know, calls will be mapped to gRPC if that's the most performant option in your cluster. State management is the one I talked about the abstraction layer over something like key value stores. Things like resource bindings and triggers work very much like triggers and bindings in Azure Functions, but we'll have a look at those in action in a minute. So as you can see, the range of services available, they go far beyond Azure. It's nice as a Microsoft employee to be able to stand up and say, here is a set of services that talk to other clouds, right? Because I'm a realist. My customers are working with multi-cloud a lot of the time. So it's nice to have something that is able to talk across those boundaries. Now, a quick caveat in that where I said Container Apps was an opinionated implementation. In practice, that means that some of these integrations aren't available yet. So the ones that I've certainly used, so observability is there, bindings and triggers, state stores, I think PubSub is there. I've not used that one personally. Secret stores is pretty limited in what you can and can't do at the moment. And secret stores is currently limited to Kubernetes secrets, but that is going to change, right? The team are actively working on producing additional integrations with these things. So let's go to our second demo video. We'll have a look at a demo with Dapper. So again, we've got our environment there, and on the environment itself is a thing called Dapper components. And what we're going to do is we're going to configure this in code in a minute. But these are where your components, so these are not tied to your application, they are configured on an environment, okay? Which means you abstract away the service implementation from the code that's being written. So we're going to deploy this again with a bicep file, and I'm going to set up a whole set of environment variables and get some prerequisite stuff. That's not the important bit, really. We're going to get a reference to a storage account, and our storage account is we're going to use a storage queue in this. And we're going to have two queues. We're going to have one that we read from and one that we write to. Okay, so I'm going to define these components now. I think I've sped this bit up, hopefully. And I'm going to define a read queue. Yeah. And the important part here is the name I give this. So it's going to be called read queue on the next line. Come on. Type faster or past me. There we go. So we're going to do that. And I'm going to give it a name. And then I'm going to provide a whole load of config for setting up the connection to my storage account. So this is the important bit. I've called this read queue. If I could spell it. Clearly I couldn't at the time. We're going to tell it which container app environment it belongs to. And then now I've sped it up. Good. So we're going to say that this is a bindings.azure.storage queues, which means it's looking for an Azure storage queue, which means that the metadata that I provide here is going to be very specific. So it's going to need a storage account, and we're going to provide some details here. We're going to need a key to be able to access it. And we'll set all these up in a minute. And then I'm going to give it a queue name, and then I'm going to set one of the parameters on the queue just to say that I don't want base64 decoding, just because it messes up your demo. And then we're going to provide some details of where those secrets are found, so those secret refs. And these will ultimately be stored as Kubernetes secrets on the cluster. Now, this scope is an interesting one because this scope allows me to define which container apps can use this this Dapper component. So I'm just giving this a name, and I've got a predefined thing. And now we're going to define these, and I'm pulling these secrets straight from the storage account that I have available. So I'm going to go and get the key there, and that will be stored in a Kubernetes secret. And then I'm literally going to copy that and create a copy of that called write queue. So I've got two versions. I've got a read queue and a write queue. And then, because again, this is a bicep file, we're just going to do a straight deployment to get that back up into our environment. Need to make sure I have my resource group configured properly, which I didn't, so I have to paste it back in again. Go. And we can do the deploy again. Come on, did I stall? So again, sped up massively. Deployed. Don't you wish all Azure deploys happen that fast? So now I've got these two components deployed, and they're both deployed on my container app environment. Now I need to do something with them. And I'm going to go and create another .NET application here, just because it's a simple way of doing this. I'm going to create a new, interestingly, I'm going to create a new web API. So it's going to be very similar to the one I created before. So a web API is going to have endpoints exposed over HTTP, and it's going to be able to write out to HTTP. That's all it's going to be able to do. So at no point here are we talking about using an SDK to talk to storage queues. We're just talking HTTP. That's all we really care about. So let's go and open up our application. And it was very similar to before. There's nothing in it. And I'm going to add a single request on here. I'm going to add a package in just to make my life easier for dealing with Dapper. And again, all this is doing is just building HTTP requests for me. It's not doing anything fancy. So we're going to bring that in, add that as a using statement. There we go. Now, all I'm going to do now is to add something that will accept a post request. Right. So I'm not doing anything to do with storage queues. I'm not defining any kind of there's no SDKs being brought in to do that. It's purely around, this is going to be effectively an HTTP API that will accept requests on this path. And you're interested to know that the path is called /read queue. And it's no coincidence that matches the Dapper component that we created earlier. And what Dapper is going to do is when a message is received on that queue, it's going to take the body from it and then forward that request onto my HTTP endpoint. So I never need to think about queues or triggers for those kind of things. All I need to do is to write HTTP. And then we'll speed this bit up again because I'm just going to do some processing on that. And then the bulk of this is about me building something to write back out to another queue. It's basically building an HTTP request to write back out again. Okay. There's some errors in there, which I need to import another library for. There we go, which is just the MVC library. So I've not got anything again. I'll reiterate this again. There's nothing to do with storage queues at all in there. So now I'm going to create my Docker file as I did before. This is very similar to what we had before, so there's not a lot of point in doubling down on that. And we're going to use that AZ ACR build command again to deploy that up to my container registry so that that image is available. Same as before. Rapid deploy. And again, this would usually take a couple of minutes in the real world, so to not waste your time, we've sped this up a little bit. There we go, build, done, happy days. So we can now go into our container registry and we can see that we now have that additional image there ready on V1. Okay, so I'm now going to need to deploy that up to a container app, and this is going to be largely the same as we did before. So I'm going to create a bicep file, dapperq.bicep. And this will look remarkably similar to what we had before with a couple of exceptions. There we go, I've just pasted the whole thing in this time rather than having you watch me type it. We've told it which scope we want to use. Now that scope needs to match the same thing that was defined on the Dapper component. There we go, see it there as well. And then as we scroll down, you can see this is all very similar to before. I'm only using a single revision mode here, which means there'll only ever be one active at a point in time, which is fine. It's not available externally, so it's an internal pod here. And we've enabled this Dapper port here, which is basically said load the sidecar. You can see a bit further down. So Dapper's there, and we've said load the sidecar. My app is available on port 5000 this time, and my Dapper scope is going to be passed in so I can use that stuff. The only other minor change from before, scroll down a bit, is that we've now got some scale in there, and I basically got a min and a max just to say I only really want one of these up and running all the time. And the only reason I've done that is because it speeds up the demo to always have an instance running. We'll come on to scaling in a moment. So let's just deploy that one up. And we do that using the standard methods again. That's deployed. We go into our container app environment. You can see that my app should now be deployed. There's my Dapper queue. I've got my thing up and running, so my container is up and running. So I can now go into my storage queue. And what you'll see here is that Dapper actually created those queues for me. I didn't need to worry about any of the setup for any of those queues. It's done all the work to create this stuff. So I can go onto here. I can drop a message in. Don't decode it, otherwise it messes things up. Just give it a number. Send that message. You'll see that appear in the input queue briefly. The pod will then pick it up, and it'll get relayed to the output queue. We go into my output queue. You'll see a new message is in there, and that message says new order received from, with that ID in it. So again, I've been able to now do stuff with storage queues without caring about storage queues, right? And the advantage about this, and the important part about this, is if I suddenly said storage queues are not what I need to be able to do here, let's do this with service bus. I could change the Dapper components without changing the code, and everything would still work. If I wanted to go and use something third party, if I want to use something like RabbitMQ, I could do that, change the Dapper component, the code would still work as is. Over that. So nearing the end now. Now, it's all very well having a container app that can respond to events from an external service like a queue, but the real power of serverless platforms comes from the ability to scale to meet demand. Now, one of the advantages about using things like the horizontal pod autoscaler in Kubernetes is that it scales really fast because they're really lightweight containers. Adding new instances to a cluster happens really, really quickly. Now you couple that with Azure Container Apps, where you can scale to 0, so you can effectively have nothing running where you're not paying for it. An event happens, suddenly you're paying for it, like paying for the demand that you need, and then it all scales back down again. So if you did this on a Kubernetes cluster now, you would enable this thing called the horizontal pod autoscaler. And then you'd have the ability to scale up and down based on incoming HTTP requests, memory, or CPU pressure. I think of the 3 it supports out of the box. If you want the Azure function like scale on a resource, scale on an external thing, scale on a custom thing, you're going to need this project called Cader. This is another open source project. It's the Kubernetes event-driven autoscaler. And this lets you scale any container based on custom criteria from a supported source. Again, this is not an Azure thing. Like some of those custom sources are, if you want to scale from something in AWS, or if you want to scale from something in GCP or from on-prem, you absolutely can do that. The advantage of Azure Container Apps is that you've got Cader installed by default. You've got a version of Cader that is installed, and we will follow updates for that as we go along. So let's just take our existing example that we had there and run the video again. So this is the same one we were just doing before. We're reading and writing from our queue. But actually, we want to scale based on that queue size. So if there's lots of messages that get dumped in there, having only a single message, a single thing processing that is going to take a while, particularly because I've got that thread.sleep in there that sits and waits for a little time. Oh, my camera's frozen again. Bring that back up again. There we go, back again. Where's that stopped? Where's that paused? So you saw before we had this scale section in our bicep file. So the first thing, and the most fundamental thing we can do is to scale based on like memory pressure or CPU pressure. And we could do that simply by changing these values. So I can say that I want to scale to 0. So if there's nothing needs processing, then don't have any issues, don't have any instances there running. And we want to say, let's scale to 5. Now, if I want to scale, and this is where CADA comes in, if I want to scale based on my queue size, I can add what's called a custom scaler on there. And the way that that works, this is slow typing. And we're going to add rules. And we're going to add a rule which basically says scale on my queue. There we go, queue-based scaling. And we're going to use a custom scaler. And the type of that custom scaler is going to be one of the supported CADA types. In this case, it's Azure Queue. And then we're going to provide it some details as to how we're going to authenticate with that queue, because CADA needs to authenticate differently from the Dapper pieces, because this is now part of the container app setup here. So we're going to give it a name, which we know. I'm going to set up all these variables later on, so that's why the red squiggles are there for a minute. And we're going to give it a queue length. So I want to scale if there's only one instance, is there? So for every instance, I want a new pod or a new instance of my container app. This is the storage account we're using. And then this is how I'm going to authenticate with this. And we're going to use some Kubernetes secrets here to do this. So we're going to say, I'm going to use a secret reference called storage account key, I think I call it. There you go. So I'm going to create a connection string. And I'm going to trigger it based on when connections happen. So basically at the point where my container connects, my container starts up, connect to that storage account, and then keep watch on when that data arrives. So now I need to define some of these variables just to make this work. Okay, briefly go and grab these. So we're going to add, there you go, there's my storage account. So I can go and grab that thing. I need to pass in the parameter of the storage account name. So I'm going to define up here, and my connection string ref, which is just a bit of text that I put on there just to make sure it's consistent in both places. That's there. And then I just need to provide my storage queue input name somewhere. There we go, which is the queue we're going to scale up. So that's going to be our input queue at this point. And then I just need to define some secrets now. And these will be effectively Kubernetes secrets. There we go. And I'm just using the values. So I'm doing a list keys on there to go and grab my primary connection string. We're hoping they're going to bring in the managed identity support for this as well at some point, but it's not quite there yet. So we're going to scale whenever there's at least one message in there. For every message, we want another instance to be applied on my queue. So let's deploy this up. Wakey, wakey. Yep, it's good. We've seen it. Past me. There we go. I need to change my revision suffix because I'm deploying a new version. And there's a reason why that's added on at the end, is because I made a mistake when I recorded these. So if we now deploy that up again, that'll now deploy very quickly. And then we can go on and see in our container app environment, and see our Dapper queue in our container app. And we can see that we've got scaling defined on there. So we basically said, this is the range I'm going to do this. And this is to show you that you can do all of this stuff through the portal as well. Now I've got a metric set up, and this is one of the out of the box metrics that shows how many instances, replicas of my container app I have running. and I'm just going to dump some traffic at it, and I'm literally just doing a loop, passing 100, dropping 100 messages onto that container app. And what you'll see is over a few seconds, you'll see a sudden spike where it surges up to the 5 instances, processes all the messages, and then dies down again. Okay, it's a slightly compressed and artificial timescale on that one, which is why it looks a bit weird. Okay, I think that's a lot. Back. So let's just finish with a little bit of discussion, or a little bit of kind of slide on kind of the Azure Containers portfolio as it stands right now. So we've got things like Azure Kubernetes Service and Azure Red Hat OpenShift, and they provide you access to a full Kubernetes cluster. As a user, you're in full control of all aspects of the cluster, including ingress, networking, maintenance, and scale. The downside to that is you're in full control of all of those things as well. Now, Azure Container Apps operates at a level above the cluster, where you only have to really worry about your app itself. Cluster management is handled by the service, even though it uses Kubernetes under the hood, but you just don't have access to any of those APIs. Now, Azure Container Instances provides a way to launch containers with kind of hypervisor isolation. It provides a container, and it's a container is probably the distinction here, as a unit in Azure. It's a really low-level compute option. If I've got a container that I want to throw up and service, it doesn't handle kind of the microservice interactions and the orchestrations between them. It's literally, I've got something that I want to, that is in a container that I want to throw up and run and then have it disappear if needed. So Azure Container Apps focuses on the application level abstractions for scale. So HTTP routing, service discovery, so all of that kind of internal orchestration thing, the same way a Kubernetes cluster without the headaches of Kubernetes. Now, the other one that's also worth mentioning here, and we get into this idea of opinionated container implementations, because things like app service and Azure functions will run containers, but they're quite opinionated about how you write your code. Okay, so app service, you can run containers, but they have to be HTTP. Functions needs to run the functions SDK to be able to get those containers to run. Whereas Azure Container Apps is a way of being able to use any runtime or programming model to execute while still being triggered through the same things you would expect from Azure Functions. I think that's a big thank you from me. Thank you for listening. If you need to get in touch with me, you can find me at those places. I'm always happy to answer questions on this stuff. I will say Microsoft are actively hiring at the moment. So if you have a look at careers.microsoft.com for roles like mine, if you're interested in it, come and talk to me. I will set you up a referral link, which means that you get a cool job and I get some money at the back of it as well, so, if you get the job. So thank you very much. And are there any questions?
I don't think there are, Matt. That was fantastic as usual. I don't know why my little camera, there we go, my camera's working now. No, it's always great watching your talks, Matt. You know, the amount of detail you go into and the way that you can kind of explain it is great. I mean, that's been something I've been dabbling with on the edges, those differences between kind of container instance, container apps, full-blown, well, AKS, full-blown Kubernetes. But no, that was brilliant as usual. Really enjoyed that one again.
It's a fun area. It's a fun area to play in. It's still a very fast-moving area, so it's an interesting thing if you want to kind of like find a subject that that you can get passionate about. Then absolutely, I would totally recommend playing with that stuff. So
absolutely. So absolutely, no pun intended, eh? I don't. Sorry, Matt. Go on.
No, I was going to agree with you. It was a terrible pun.
But, no, it was a terrible pun. But no, thanks a lot, Matt. That was awesome, as usual. If everybody can show your appreciation for Mr. Fortunka before we go on with the quiz. There we go. I'm going to give you a virtual applause there, Matt.
Thank you very much.
Okay, shall we move swiftly on?
Yeah, shall I quiz it up?
Right, absolutely.
My voice holds up.
So everybody at the ready, get your browser, get your mobile device, scan the QR code.
So if you've not used this before, this is my own homebrewed version of Kahoot, although we're not directly competing with Kahoot for legal reasons, obviously. As you'll see from when we start playing, because it does look very, very similar. Scanning the QR code will just take you straight into prompt you to enter a username. Otherwise, you can just go to quizzer.co.uk and enter that code, and you can join the quiz. There we go. I've made extensive use of emojis in this because I'm not an artist and I think they look cool when you put them in a web page.
We've got about 12 people, I reckon, in the chat. So yeah, halfway there. We got two £25 vouchers again, Matt. Yeah, for first and second place.
You're in with a good chance tonight.
Here we are. Yeah. Well, I'm not. I'll play along, but I'll not be claiming any prize.
Excellent.
Sorry that took me so long. Brave was blocking it.
Is anyone waiting, struggling to get in? Anyone still pending?
Shout. I think is Audrey. Yeah, I think Audrey's struggling to get in there. Are you a sec? So. Anybody else waiting as well? Sorry, Matt, go on.
Interestingly, I had talk with a designer friend of mine today who's done some design work for it. So basically, you'll see when we do this, I am not a UI designer. It's functional and it does the job, but is everyone there? That's no one else struggling to get in?
Just put a message in the chat or come off mute if you're struggling. I think that's about right, the right number of people.
Yeah. Right, I'm going to start then in 3, 2, 1. Which of the following is not one of the foundations of Azure Container Apps? Envoy, Dapper, Cada, or Istio? Correct answer was Istio. Oh, 3 of you got that one. What is the name of the GitHub mascot? Let's see who knows the branding, whether or not the PR is working properly. Oh, it's Mona. Oh, Mona Cat. Mona the Octocat is her proper name. Well, I'm going to use that one again in another quiz because that's really good. Approximately how many 3.5-inch disks would the install for Azure DevOps Server require? And yes, I calculated this.
You've been brutal this month, Matt. Fair play. This is brutal.
The answer is 4,000. You'd need 4,000 floppy disks to be able to have the latest.
What's a floppy disk?
It's a state item.
Yeah.
What's the name of the non-Git based source code system in Azure DevOps? These are tough ones this week.
God, you've gone for it.
So there are 2 repo types in Azure DevOps. What's the other one called? Yeah, a few of you knew that one. TFVC. Team Foundation Version Control, if you want to know what that stands for. Back when it was Team Foundation Server. How much does an Azure DevOps Basic plan cost per user per month to the nearest pound? It's going to be a guess. It's £5. Most of you got that one. In container apps, how many revisions can you retain per container app? I did say this during the presentation, so this is the who was listening to what I was saying. The correct answer is 100. Only 2 of you got that. Oh, I think this is going to really split the scoring here. Can you run Windows containers on container apps? The correct answer is no. No, you can't. I'm sure it's going to come at some point, but which of the following doesn't support running containers in Azure? Azure Spring Apps, Kubernetes Service, App Service, or Azure Logic Apps? Azure Logic Apps. Yeah, no, Spring is the Spring for Enterprise, Azure Spring for Enterprise. So it's got a new name now, but it's the Java-based hosting platform which does support containers. Which of the following is not a supported CADA scaler? This is just going to be pure guess, I think. I didn't mention it in my talk. The answer is GitHub Actions. You can scale based on Azure DevOps Pipelines in container apps. I don't know why you would want to do that, but you absolutely can do it. Lastly, how much did the James Webb Telescope cost to build? Some fantastic pictures that came out recently. So, as any sort of space nerd will tell you, they were amazing. $10 billion. Well done. So let's have a look. And our winner for tonight is Abby. Abby.
Yay!
I'd take a picture of that. Abby and Graham, Griffiths, I'm assuming that's you, Graham G. There's nobody else with Graham G, is there?
It is me, yeah.
Cool. Do me a favor, I don't know if you're following me on Twitter or we're connected on LinkedIn, or you just want to drop your email in the chat here, but ping me a message on any platform. I'm Johnny Chips on Twitter or John Lunn on LinkedIn. Drop your email address over and I'll get those vouchers organised for you both, Abby and Graham G. Well done. And Matt, that was brutal. That was brutal. I think I probably got 2 of those right, so thanks for that.
I don't want to give you an easy ride every month, you know.
Do you know what? Bring back the old Matt. That's all I'll say. Just proper sweating then. I don't know if it was the heat or whether I was just getting them all wrong. I don't know. But anyway.
They were quite tough though. So.
Awesome stuff. Right. Shall we bring an end to the event? Let me quickly get my screen back up. But yeah, well done, Graham and Abby, for winning that quiz there. Right. Okay. So cool. Leaves me nothing more to say but thank our 2 fantastic speakers, both Audrey and Matt. Hope you all agree, 2 fantastic talks tonight. This event is being recorded, so if you want to watch them back, I'll get them up on the YouTubes over the next couple of days. Watch the socials for the tweet out showing that. Yeah, thanks both. 2 awesome chats. And final slide, bookmark. The next event is the 17th of August. The agenda will be released fairly soon. We're just waiting on confirmation of one other speaker. If you can, leave us some feedback, scan that QR code or browse that link and leave us some feedback. But yeah, and thank you all for joining. Like we say, reach out, send us feedback, let us know if there's anything in particular that you're looking to get a talk on, and we'll see if we can get that arranged for you behind the scenes. But for now, Matt, I don't know if you've got any other closing comments.
No, I think I've done enough talking for tonight. Thank you.
You've done well, and thanks for stepping in there, Matt, on that one. That was an awesome talk. In fairness, you didn't have too much time to prepare for that one. It was great.
It was
awesome
week.
Stuff.
I had a week. That's fine.
Well, now we know that you can do that, Matt. No, that was awesome. Thanks, everyone, for joining. Have a great rest of the week. And, yeah, we will catch you all next month. Ta-ta for now. Thanks all.
Thanks all.
Thank you very much all. Bye.